GemmoFTIR applications for emerald. Besides being the standard spectroscopy technique for the detection of fillers in emeralds, FTIR is even extremely effective in the identification of its synthetic counterparts. Before to start operating, it's always important to remember the stone must be clean as much as possible. External contamination, commonly from fingerprint oil, can affect the spectrum of our sample, and for emeralds this is particularly problematic since the contamination peaks overlaps the area where organic fillers are detected by FTIR. Our task is to check if this emerald is natural or synthetic. Click on Background Spectrum. Let's put the stone table down on the sample stage. Click on Scan Sample. Now that we have the spectrum, let's open the Drift library and select emeralds from the group. In the application menu, there's a list of the most common synthetic emeralds. We will open them one by one, checking their correspondence with the tested stone. Click on Flux Melt. A typical spectrum of a synthetic flux melt emerald will overlap our scan. The most important features are highlighted and described. It's no matching, so we move on the next one. This is hydrothermal molossi, and again, no match. This is hydrothermal tyrus, and it's not matching either. The last one is the hydrothermal Byron, and is matching perfectly. Our stone is indeed a synthetic emerald made by Byron hydrothermal process. The next task is to check if this natural emerald has been treated by impregnation and, if that's the case, what type of fillers has been used in the process. The background spectrum has been taken only a while ago, so there's no need to take it again. Let's put the emerald on the sample stage, table down, and close the lid. Now click on Scan Sample. Click on the Emerald Clarity Enhancement Analysis button. This window displays a close-up of the spectrum in order to enhance the critical zone where the fillers show up, roughly between 2800 and 3100 cm-1. On top, such area is further magnified and the peaks found in the spectrum are highlighted and labeled. This window displays a list of matching peaks between the most common fillers used for the treatment and the stone we have just tested. It's rare to find an emerald treated by a single element. Quite often the treaters use a customized mix of multiple agents. These recipes are of course secrets, and unfortunately many of the single elements used have very slight differences from each other in their spectra. The result is that it's often practically impossible to precisely identify the fillers. More easy is to make a distinction between artificial resins and organic fillers. So in this case, we have not a precise idea of the mix used to treat this stone, but looking at this list, we know for sure it's an artificial resin. In the last window we can read the results. There is evidence of clarity enhancement and the degree suggested by the software is minor. About this particular grade we should always remember emerald is not homogeneous and the possible pattern of the impregnated fractures are endless. The minor grade reported for this stone is valid for the current orientation on the sample stage. If the stone would have been placed in different positions, different grades could have been reported. For this reason, it's suggested to test emeralds with different orientations in order to have a more precise and homogeneous idea about the extent of the treatment. Since the infrared beam is not capable to scan the whole stone, it's highly advisable to use other standard gemmological procedures like the microscopic observation to make the call about this grade. It even needs to be stressed that this grading system is not based on objective and measurable data, and hence it could be differences of interpretation depending by the operator.